In this video, we're focusing on trigonometric identities. So the first thing we want to look at is our reciprocal trig functions, such as cosecant or cosec, secant or sec, and cotangent cot. Now, cosec is 1 over sine, sec is 1 over cos, and cot is 1 over tan. Now, if you're trying to find cosec, it's hypotenuse over opposite, sec is hypotenuse over adjacent, and cot is adjacent over opposite. It's just tan flipped, cos flipped, or sine flipped. So we're going to do an example here, and we have sine theta, and we know it equals 5 over 13. Now remember, sine equals opposite over hypotenuse, so I know my opposite side is 5 and my hypotenuse is going to be 13. Now it's best to draw a triangle for this. So now I've got my triangle here, I've got a right angle. Let's say that this over here is theta, so that means this is going to be 5 and this is going to be 13. I still need to find my adjacent side down here, and that's just going to be Pythagoras' theorem. So 13 squared minus 5 squared, and that gets you 12. So I know 12 goes there. The next thing I want to do is, I've been told to find cosec, sec, and tan. So I know that cosec is 1 over sine, or it's hypotenuse over opposite. So in this case, my hypotenuse is 13 and my opposite's 5. I then go and find sec, which is 1 over cos theta, or hypotenuse over adjacent, so 13 over 12. And then cot theta is 1 over tan, or A over O, which is going to be 12 over 5. Okay, so start by creating a triangle from what the information you're given, and then using that triangle find your other unknown side, and then you've got your formulas you can just substitute your values into. So the next thing we're going to look at is our complementary angles. So some of these you may have already seen before. So we know that sine theta is the same as having cos 90 minus theta, and it works the other way around as too. Cos theta is the same as having sine 90 minus theta. Some of the new ones you may not have seen is tan theta equals cot 90 minus theta, and the other way around. And then we have sec theta equals cosec 90 minus theta, and then again, the other way around. When you are expected to solve questions like this, usually you have something like your example there where it's tan 70 plus cot 20 minus 2 tan 70. The goal of these is to try to simplify them down as much as possible. The first thing you should look for is, well, can I get them all into the same ratio? So I want them, in this case, because there's 2 tans already, I want to make the whole thing tan. All right, so I'm looking at that cot and I'm going, well, how can I convert cot 20 into a tan value? And I know that I can use cot theta equals tan 90 minus theta. So that's what I can do. I'll go cot 20 equals tan 90 minus 20, or tan 70. So I'm going to rewrite this up here as tan 70 plus tan 70 minus 2 tan 70, which ends up all cancelling out and we're left with a 0. Other things to keep in mind are, it's not always going to be as easy as that, but a lot of them are just about that conversion. You need to convert them all to the same type of unit or ratio and then go from there. Something else to consider here are your tangent identity, which is very commonly used. So tan theta equals sine theta over cos theta. And then if you have it the other way around where it's cos theta over sine theta, it equals cot. That's a very commonly used one. Tan theta equals sine theta over cos theta. So it is good to keep in the back of your head. Some of your other Pythagorean identities are where you've got squares. So cos squared theta plus sine squared theta equals 1. You've also got 1 plus tan squared theta equals sec squared theta. 1 plus cot squared theta equals cosec. So your main one is that cos squared theta plus sine squared theta. The good thing about that is you can rearrange it just as if you would any other equation. So for example, let's say I wanted to find what cos squared theta was. I would minus, so if I go over here, cos squared theta plus sine squared theta equals 1. I could go minus sine squared theta minus sine squared theta to get cos squared theta equals 1 minus sine squared theta. So you can rearrange these to get it to a form that is usable for whatever the question is. Alright, so here we have an example. We have tan theta, cos theta. You might look at it and go, well, I don't know what to do. I can't do anything there. So the goal here again is let's try to get things the same. I'm going to focus on the tan because I know tan can be converted into cos and sine. So remember, tan theta equals sine theta over cos theta. So that's what I can do. I'm going to change that to go sine theta over cos theta times cos theta. That ends up being sine theta cos theta over cos theta. And those coses cancel out. So I'm left with just sine theta. So tan theta cos theta is the same as just sine theta. Alright, the next thing we're looking at down here, cot squared x plus 1. Now I already know that from my notes that 1 plus cot squared theta equals cosec squared theta. So I can just change these here. So I know that my cot squared x plus 1 is going to be the same as having cosec squared x as my answer. So with these type of problems, it's about identifying the patterns and where to change things to get them into a way you can. Sometimes you'll go the wrong path and you might need to double back and go from the beginning, and that's okay. Try to find the patterns by converting things into similar things that you can cancel out later on.